22? Brutal. Absolutely brutal. Some of these are worthless. I'm going to deem this one worthless. I am going to deem some of these worthless. So we've learned about what we need to do, right? No. Here, DDIA, data models here, probably here. No, it's okay. So some of these just aren't worth anything. Maybe that's what we do. Maybe we go through chapter 2 and we start refining some of these, because like it's just kind of a waste of time, you know, to go through some of these cards. Let me see here. Did I actually do all this? This is gonna be worthless. Maybe. No. Let's take the time. Let's try this. I don't think I took notes here. someone doing air squats in the street. That was funny. Maybe, hold on. So I've looked at these a bunch. Let's go here. All right. Wait. No. Hold on. Go back to OBS. We're gonna open actually ChatGPT, and then we're gonna open VS Code. But we're going to do this one. Okay. But now we're gonna close this and go to chapter 1. We come here. No. Oh. Let's just close the other one. All right. Now that we have this going, let's see. But let's go back to did I do this in the wrong one? Oh. Oh! What is a fault in a data-driven, data-intensive application? Why is it important to distinguish it from a failure? A fault occurs when a component deviates from its specification. It's important to distinguish from a failure because a robust system should be designed so that faults don't necessarily cause user-visible failures. Whoa, dude! What is a failure? In the context of a system and system reliability, oh, I see. And how is it different from a fault? System failure means that the system can no longer respond to users. Where a system is designed to tolerate some faults, a failure means the system is no longer functioning. Failure is when the system stops functioning correctly or serving. Unlike a fault, a failure is visible to users. Okay. So let's apply this. I should check this into Git first. Save that and then open OBS. And now we need to reset Hinky here in chapter 1. Whoops. Let's do this. I'm just removing all the SR stuff. Actually, let's keep it for now, and then let's see. This is sick. This is cool. Now, can you audit these flashcards for overlap? To combine some of them. I don't want to add a third one, thank you. Wow. I don't really want more flashcards, you know? Dang. I like the Alright, so what is the difference between a fault and a failure in system reliability, and why does it matter? A fault is an internal problem, like a bug or hardware error, that may not immediately affect the user. A failure is when the system stops functioning as expected from the user's perspective. Reliable systems are designed to tolerate faults and prevent them from causing failures. Apply that. Loving this. Alright, now that we have that, let's remove this. Yeah, let's what does scalability mean in data? Alright, what was this? Flashcard out. Scalability, keep as is. Load parameters, throughput, and response time. Combine or add conceptual bridge. Instead of 3 cards, you could do I'm just looking. Huh. What does scalability mean in data-intensive systems, and why is it critical? Scalability means how the ability of the system to cope while load parameters are increased or decreased. So I think this is good. I feel like I've read through the chapter, I had flashcards, but this is like refining them more than anything. No. Alright, so this should give me like all new flashcards, right? There's only two. Oh, because so I need to remove all of these. So this is going to be tough, right? Because now it's going to treat them as brand new. Very, very tough. Why is it saying there's like more, you know? In chapter 1, I feel like it's saying that, right? There's 1, 2, 3, 4. So now if I look at chapter 2, this is just going to mess me up so bad. Let's do a similar practice here. What time? Oh, it's already been 25 minutes. All right. We have a loop here that we can use. I think it's good, and we'll do it. Should I just do it all in one day? Because I could probably get this done for chapter 2 at least. All right, let's just do it. How can I improve these cards? But what is this? Love this one. What is this? I don't know what this is. I don't want this change. I don't know what this is. Let's see. Okay, so that's reduces one. Now schema on read, schema on write. That what's the difference between on read and on write? Okay. When is the document model preferred over the relationship model? And it just added some weird. Okay, let's apply this. Get rid of this. so let's spend some time on these. What is the difference between a fault and a failure in system reliability, and why does it matter? A fault is when a piece of the system deviates from its spec. A failure is when the system as a whole stops functioning. And it matters because a system should be able to tolerate faults without failing. A fault is an internal problem, like a bug or hardware error that may not, I forgot, the effect on users, yeah. A failure is when the system stops functioning as expected from the user's perspective. Reliable systems are designed to tolerate faults and prevent them from causing failures. Alright. What does scalability mean in data-intensive applications, and why is it critical? Scalability means scalability means an ability system, or a system's ability to cope with increased load. It's critical because things need to work. People rely on some of these systems. Increased load without performance ensures the system can grow efficiently as demand grows. What are the differences? Latency, response time, and throughput. So latency is the time the request waits to be serviced. Response time is the amount of time the user's waiting for the request. So it would be latency plus the actual time it takes to service the request and return it. And throughput is a system's ability to perform units of work in a given amount of time. I wonder, are you able... Let's see what it comes up with. This will be interesting. Is this even on my screen right now? Yeah, it is. Oh, but OBS isn't. All right, let's see what it does. All right, so not the best. That's funny, actually. All right. Let's see. Maybe we could find. Let's just go online real quick. Dude, some of these I really don't understand what they're saying. That's crazy. What? Hmm. Is that latency? I thought latency. Wow, I thought you could find this a lot easier. Hmm. All right. What are load parameters and system scalability, and how do they help evaluate system performance? It's a set of numbers that define performance of a system, and they help evaluate system performance because we can measure things like throughput to evaluate the system's performance. Yeah. Load parameters are key metrics that describe the demand placed on a system, okay, such as, okay, they help quantify system load and guide scaling decisions. Yeah, okay. So let's go look at these real quick. What are key characteristics of the relational model? SQL, joins, tables, schemas, and normalization. Forces normalization, yeah. Alright, save this. That's good. What is the difference between imperative and declarative? So, well, how do declare? Shit. Declarative, let's get this one before the time runs out. It's a minute 40. What's the difference between imperative and declarative? A declarative language? Okay, I think imperative is imperative is when you tell the computer how to do something, like the exact steps to take. Declarative is where you describe what you want, and the computer is going to determine how it's going to do it. Yes. Control flow and steps. Declarative language lets you specify what you want, leaving the database to figure out exactly how to execute. When is the document model preferred over the relational model, and what are the main advantages? Document model is preferred when the data looks like a document, when you can tolerate duplication, and when you want to take advantage of data locality. Naturally grouped and read together, locality, flexible structure, simple relationships. Advantages include flexibility, better locality, and alignment with application. So that's hard. Alright. Okay, I think this is productive, even though I didn't get much done today. I think some of these flashcards will be way better, and if I can reduce the total number of flashcards, I think it'll be super helpful, because it's actually getting pretty painful, so I need to manage just how many there actually are. Anyway.